Skeletal muscles are attached to bone at each end by tendons. This attachment causes the bones and thus body parts to move when our muscles contract. Furthermore, the nature of the attachment affects the efficiency of movement in terms of strength, speed, and distance moved. Now, muscles work by way of lever systems, which is a rigid lever, such as a bone, that moves on a fixed point called a fulcrum. A teeter-totter is a good example of a lever system. The weight of each person on each side represents the force and the load, while the pivot in the middle represents the fulcrum. If the fulcrum is placed in the middle of the board, two people with the same weight will balance the board. Now, moving the board relative to the fulcrum will result in unbalance, and that'll make it easier for one person to push the other up. Just as moving the fulcrum of a teeter-totter can increase the effectiveness of a force, the nature of muscle attachment to bone relative to the joint increases the efficiency of muscle contraction and thus body movement. Any lever moves when a force or effort is great enough to overcome a load or resistance that would otherwise resist movement. In this lesson, we will describe the three basic lever systems utilized by our muscles and bones for body movement and body support. Well, let's take a look at first-class levers. While the body has relatively few first-class levers, they are easy to understand as they resemble a teeter-totter. In such a lever, the load is located on the opposite side of the fulcrum as the applied force. For example, head extension is a good example of a first-class lever system. Here, neck and back muscles apply a force to move the head. The weight of the head is the load, and the fulcrum is the joint between the skull and the vertebrae. Let's move on to second-class levers. In a second-class lever, the load is located between the force and the fulcrum. A wheelbarrow is a great example of a second-class lever system. Here the wheel is the fulcrum or the pivot point. The weight in the wheelbarrow is the load, and the lifting of the handles applies the force to move the load. What about in the body? Plantar flexion, or standing on the balls of our feet, is an example of a second-class lever in the body. Here the balls of the foot is the fulcrum, the weight of the body is the load, and the contraction of our calf muscles provides a lifting force or effort. Now, this type of system allows a relatively small force to move a relatively large load. In fact, moving the force further away from the load increases the strength of the lever system. However, speed and distance of movement are compromised at the expense of this increased strength. In other words, a relatively small force moves a large load a relatively short distance and moves it slowly. Now let's talk about third-class levers. Third-class levers are the most common in the human body. Now here, the force is applied in between the load and the fulcrum. Now, a broom is a good example of a third-class lever system, where one hand on the top of the broom represents the fulcrum or the pivot point. The force is applied in the middle of the broom by your other hand, which will then move the broom being the load. Now, an example of a third-class lever in the body is forearm flexion, where the elbow is the fulcrum. The biceps apply an upward directed force to the forearm. Now, the load is the forearm itself and anything that may be held in the hand. The effect of a third-class lever is just the opposite of that of second-class levers. You see, with third-class levers, speed and distance of load movement are increased, but at the expense of decreased or compromised strength. In other words, a large force is needed to move a relatively small load far and fast. In fact, the force required to move a load is increased the closer it is to the fulcrum. So with forearm flexion, the load, or the weight in the hand, is 6 times further from the fulcrum than the applied force, that is, the biceps brachii attachment to the forearm. Therefore, the force must also be 6 times as great as the load in order to move it. However, the load is moved far and fast. In summary, body movement occurs when our muscles contract. Our muscles utilize 3 different lever systems to move our